Hi everyone. In this video, we are going to go through and cover as much as possible of the details about 5G CSI-RS, 5G channel state information reference signals. It's one of the most important channels or reference signals in 5G. And if you can remember, actually this was already, it's not a new concept in 5G because it was already introduced in LTE release 10. But if you remember that 4G was more relying on the cell-specific reference signals, which is we call it usually always on because it was being transmitted all the time in the frame, and as you know that it was acquiring the complete bandwidth. However, in the 5G, they are trying to reduce this or avoid this concept of always on through introducing a lot of reference signals. One of them is the DMRS, and the one we are going to cover today, which is the CSI-RS. However, this is like this concept on CS is being revised in NR with more sophisticated algorithm or technique. So let's move forward to see what is today on. Okay, in today's sessions, we have many different topics to be covered. Actually, I will try to split it into two different videos just to try to simplify it as much as possible because it might take like a long time. So that's why I prefer to split into two videos. So let's go through the contents. Actually, the first point we're going to cover what is the main function of the CSI-RS. Then we'll go through the key characteristics of the CSI-RS. Then we'll be covering the main types and categories, which such as the non-zero power, zero power, CSI, interference, measurement, RS, and so on. Then we'll be covering the main parameters. Just I will go through the main parameters of CSI-RS, which is covering the resource allocation and so on. I will give a quick description about all of them. Then I will be showing that which messages from layer 3 can be used to check those parameters. Then we'll try to visualize, after we'll try to visualize some of these parameters through, because these parameters mainly controlling the frequency at time domain, location or allocation or structure of the CSI-RS. So this one we'll try to visualize it after we show the parameter description and so on, just to try to make it more easy and so on. Then the last part we give high-level introduction about the CSI reference signal planning and so on, and what kind of planning is being considered in the CSI-RS. So moving forward, let's cover the first part. First part actually it's about what is the main functions it can be used in CSI-RS. Actually, CSI-RS it's cover multiple or multi-purpose functions in the downlink. Like if you can see the first part here, it's covering something called CSI reporting. What it means by CSI reporting. CSI first is stand for channel state information. As you know that initially they would be being like sending the configuration or the transmitting the CSI-RS to the UE in the downlink. Then UE will start obtaining the channel measurement through the CSI-RS. Just to QCSRS to acquire the channel measurement, then it will report something called CSI, which is channel state information. And this part actually it's covering many of different information such as CQI, channel quality indication, or rank indication, or PMI, layer indication, and also something called CRI and L1 RSRB and other stuff. This one actually it's require a separate session for the CSI because it's one of the most important. But just simply or shortly, this one like it's giving indication to the NOD about the radio condition of the UE, and this one can be used. This reporting can be used for the link budget and so on. So the UE provides CSI reports which contain this kind of information, CQI and so on. Then the NOD will be using it, or GNOD will be using it for the link budget. The second part it's about the beam management. What it means by beam management. Let's look into this figure. As you know that initially the UE will be assigned will acquire the SSP beam. Usually the SSP beam is white. The SSP beam was white. So the CSI-RS will be using to refine the initial beam which is being acquired based on the SSP, and this will try to, as you can see here, for example, this is the white one, the yellow in the background. This is the SSP. This one the NOD will be using the CSI-RS to refine the initial beam to try to set more directional beams as shown here. And this actually more directional beam can be transmitted using the CSI-RS, and this more directional beam can improve the link budget as well, and also quality and so on. So this is one of the function. And also I will try to have additional video for the beam management in general, because this, for example, called something called phase 2 or P2. We have three phases in beam management with P1, P2, and P3. P3 usually for the high frequencies. However, I'll try to cover it in different video because this is also one of the most important function in 5G and so on. So that as a general, as a summary, CSI is used to refine the initial beam which is the SCP selected, then it will set more directional beam using the transmitted CSI reference signal. Then the third function, it's about the connected mode mobility. This is like the handovers. Handovers usually is controlling by the SSP blocks, but still CSI-RS can be used as well to control the mobility through that detecting the user can measure the CSI-RS report, the RSRB and so on, RSRQ to the NLB and GNLB, and GNLB can take the decision based on the reporting stuff and so on. But mainly and currently now, the handover is being controlled by the SSP. So yeah, as mentioned here, handover can be triggered, RSRB, RSRQ and so on. Then this part is related to the radio link failures or RLF detections. Actually, as you know, first of all, that the RSC is responsible for detecting the radio link failure. This radio link failure, and actually the BTS is usually sending RSC signal to configure a use a set of radio link monitoring, like for example this kind of timers and counters being set through to the UE through the RRC signaling, and then you will be using this one to detect the radio link failures, and this actually can be used through setting some particular thresholds and blare and so on, and this still the UE can use the monitoring of the CSI-RS to detect the radio link failure and report, for example, out or in of sync and so on. For example, if there is 3 out of sync, so that will be starting this 3T10 timer. If there is 1 or 2 in sync is being acquired, then this means that the UE is still in connection and the radio link failure is not detected. However, if the 3 out of sync, as for this a particular example, which is in 310 is being detected, then if the user failed to make any in-sync, then this will be detected or be considered as a radio link failure detected. And this is all measurement can be done through the CSI-RS. So this is one of also the functions of the RLF detection of the CSI-RS, which can be used through measuring the CSI-RS. Then this part is about the beam failure detection and recovery. It's also the similar, but this, as you know, that this beam recovery, it's like MAC-clear responsibility for the for the beam recovery and so on. And this is also can be through measuring the CSRS. For example, if you're having a very bad level and so on during the beam switching and so on. So, for example, the beam failure instance will be reported, and if this is having like based on the configuration of like achieving a particular thresholds, this they can consider as beam failure detection, and after the unit B will start trying to make the recovery and so on. So still the CSR is also is being used for this part. The last part actually it's related to the TRS or tracking reference signal. Actually, tracking reference signal, it's like a subset or a type of the CSI-RS. This is like tracking reference signals. It's usually using almost the same concept that the unit B is transmitting at particular reference element. But however, the TRS is having the highest density of resource element. What means by high density? For example, compared to all the CSI reference signals, for example, here it's being transmitted 3 times, as you can see, but it's using single port. And in general, TRS is being used for fine tuning of time and frequency synchronization, just to like, for example, it's being used to track the time and frequency variation with a higher resolution. That's why this TRS also is being used by is using the CSRS in order adapted by 3GPP to as a solution for this of time tracking and frequency variation and so on. So this is the main functions of the CSRS, which is very important functions. But the most common used one is the CSI reporting, which is the channel state information. And actually, as mentioned below here, the procedure listed above for non-zero. This is using non-zero power CSI reference signals, which is being configured for something called a channel measurement. I will be covering this part in detail just to show what is the differences between a channel measurement and interference measurement and so on. And this CSI-RS in general is being being assigned to the UE through dedicated signaling to configure the UE with the reference signal and so on. Also, this will be covered in more details in the coming slides. So moving forward, actually before going to the details, I just need to clear some high-level concept of the CSI K characteristics, just to try to simplify it before digging into the details. For example, this is the K characteristic of the CSI-RS. CSI-RS, as you can see, it's having 4 main characteristics. First one, it's related to the number of antenna ports. For example, it supported maximum up to 32 antenna ports. This this is the number of the ports from 30,000 to 3031. Then it's having this scheduling options. It can be periodic, semi-persistent, or aperiodic. And the main differences between all of them, that periodic is usually transmitted at particular slots. It's having a different configuration, starting from 4 slots, which is referred to 40 millisecond, up to 640 millisecond. And this is it's configured. We can play around it. Usually, most of the networks using, as I remember, 40 milliseconds. And we have another type called semi-persistent. Semi-persistent is similar to periodic. It's also periodic. However, this can be deactivated or or deactivated by the GNB at any time using something called MAC control element and so on. Then the last part is called the last type is called aperiodic. And aperiodic, this is event based. This is actually it's not a periodic. This just can be triggered at any time through sending DCI when required. Then we have this part which is related to time frequency location. Time frequency location, actually this will be covered in the parameters part, and also I will be giving a visualization for each of the types, some of those types. However, there is a 3GPP table which is covering all the mapping tables for the frequency and time domain allocations. We have 18 combination, that if this 18 combination covering different time number of ports, for example, different number of dynasty and so on. This is I will be covering in more details in coming slides just to try to simplify as much as possible. Then we have something called CDM types. CDM actually is referring to something called code division multiplexing, and this we can have different types of CDM. For example, here it's mentioning no CDM. This means there is no code division multiplexing. Division multiplexing simply means that, also I'll be showing in the next slides, it simply means that you can configure the same frequency time domain resources to 2 different UEs or 3 different UEs using different ports, using different units, but this is will be using this code division multiplexing to segregate or differentiate between the resources of each UE. And we have something called frequency division multiplexing, and this code division CDM types, it's having different types. Also, I'll be covering in the next slides. I will try to visualize it, and this is also part of the mapping table. Okay, moving to forward, this is one of the most important part, which is usually causing some conflict during studying or during even like reading and so on. It's related to the types of the CSI-RS types and categories. Actually, in CSI-RS, we can say it 2 types, but it's not 2 types. Usually we say zero power and non-zero power and zero power CSI-RS, but actually it's 3 types. We have something called non-zero power CSI-RS, and this is used for channel measurement, which is mentioned, for example, all the previous function which is highlighted in the first slide. This is being used using non-zero power, and this is, as mentioned here, using for channel state information, beam failure, beam management, beam recovery, mobility, and so on. And this also non-zero power can use for something called interference measurement. It can, for example, I will be showing giving a visualization for one example just to make it more clear for you. But it just measure for example, the interference from the neighbor cells, from during the multi-user MIMO from different users and so on. So we have a CSI-RS dedicated to measure the interference only. That's why we call it, for example, non-zero power IM interference measurement, or non-zero power CM channel measurement. So if you see this, for example, CM, this means non-zero power CM. This means it's used to read all this kind of information by the UE to read this kind of information or report this information. Or if it's IM, this means it's being used for the intra-cell interference. Then we have an additional uh, type, okay, from it's called CSI-RS. This is similar to the non-zero power IM interference. However, this part is called CSI interference measurement resources. This is resources dedicated to measure the inter-cell interference, and this is mainly during the SU MIMO, single user MIMO, just to, for example, to measure the interference reported or detected from a neighbor cells and so on, or neighbor sector or whatever. But this is, as I told you, it's using something called inter-cell interference, and both those 2 types are being configured within something called CSI report configuration. This is, I will be showing also the message, which you can read it from the layer 3 in order to read this kind of information. So far we have 2 types here, and these 2 types covering 3 categories. First one is channel measurement. Then we have IM measurement, interference measure for intra-cell interference. Then we have interference measurement for inter-cell interference. Then the last part is something called zero power CSI-RS, and this is configured within the BT6 configuration. And actually, as I think this is being mentioned many times, that the naming itself is kind of misleading. Zero power means it's not related to any power or anything, and even though this zero power is still, or the CSI-RS, which is called zero power, is still can having a transmission within the CSI-RS to inform the UE about many things, but the most important part it's about the rate matching pattern. And this is actually it's used in this feature, for example, to inform the UE about free resource of BDSH which can be used to increase the available resources for the BDSH and so on. Also, I'll try to visualize this part to give you more clear example about it. So in general, we have three types: non-zero power CSRS, which is used for channel management and interference measurement, and we have the CSI-IM. This is CSI-RS. This is used for interference measurement, but for intercell interference. Then we have the zero power CSI-RS, which is used actually to define a rate matching pattern. And for this part, as I told you, it still can the resources can be used by the serving cell to transmit some information to the UE. Okay, moving forward, let's now try to visualize each of those examples just to try to simplify it and make it more easy for us to understand. Okay, now let's try to visualize each of the CSI resource types just to try to make it easy, more easy, and just to try to understand it more. So the first part we're going to see, it's about the example about the non-zero power CSI reference signal, non-zero power CSI reference signals. As you can see, this figure actually is presenting here example for multi-user MIMO. As you can see, you have three different users, each is using different beam, and as you can see that there is multiple CSI resources being configured to those particular users. For example, here you can see that there is orange, this orange CSI-RS. This is for non-zero power CM, which is a channel measurement, which is being used, for example, to report the CSI channel state information, or to, for example, to detect the radio link failures, or all the other functions being mentioned before. And we have another two resource sets being configured to this particular user to measure the interference, which is called interference measurement. And I will explain why we have here two, because here I'm giving example for three users, right? So for example, this user 2 also is having the same, but it's being transmitted the CM at different locations just to avoid the interference and so on. And the same for this part. And actually, first part I need to highlight that you know that in multi-user MIMO, the special separation between the multi-user MIMO, or the special separation towards TX towards each UE within the multi-user MIMO is not really idle, right? There might be a chance for some level of interference. And in this case, it's more meaningful to generate the CQI reporting, which is being used for, reported through the CSI through measuring this particular CS channel state information channel management, that it will be more meaningful to generate CQI after actually acquiring or calculating the interference generated by the another UEs. So that's why this CSI-IM comes into the play now. This is the main rule for this one, and that's why it's being configured by the unit B. The UGB configured this part particularly to cover the interference coming from the other two CSM or channel state information from the other two UEs, just to be able to generate accurate CQI through measuring this one. So while measuring the CS channel measurement for user one, it will be detecting the interference generated by the other two users, so it will be able to generate accurate CQI. So that's why you have this kind of combination within the multi-user MIMO, and this is the main use of the channel measurement along with the interference management for the non-zero power. So this is actually, that's why each of the UEs will be configured with two non-zero power in this particular case, and non-zero power CSIM and one zero power CM. So assuming that you have only two users, so in this case you will require only two resources, one for CM and one for IM. Assuming you have four users, this case means that you require one additional CSIM to measure the interference from the user number four, and so on. So this is the main function of this particular non-zero power CSI-RS and so on for non-zero power. So moving forward, let's now move to the second example. It's about the second type, which was called, if you remember, it was called CSI interference measurement. If you remember, I mentioned that this one is mainly used to cover the intercell interference. The first part here, if you remember, also I mentioned that this one covering intracell interference. In other words, for example, interference within the same cells, which is, for example, during the multi-user MIMO and so on. So this part, CSI interference measurement resources, this is being configured by the GNOD B to the UE to be able to detect and measure the interference generated by the neighbor cells. So, for example, assume this is a figure on the left. This is a serving cell. there is some resources here, CSI-IM resources being configured. Actually, I give here pattern 0, pattern 1 because this can be one of them. The GNB usually configure one of those patterns. This is based on the parameters configuration, but just the main difference between both of them, that for example you can see pattern 0 is using 2 by 2 grid. What means by 2 by 2? That for example two resource element and two resource element here in the frequency domain and two samples. So this in general having four. This is exactly the same, but this is using 4 by 1. This means it will be using 4 subcarriers and one time domain and so on. But just in general, in summary, that this usually the GNB will be configuring only one. So I just give this one to cover all the types of the CSI-IM resources. So what will happen? That GNB will configure this one at this particular area. The UE, the UE, the GNB will not transmit anything. Nothing will be transmitted at this particular example. The serving cell will not transmit anything, so the UE can measure the background interference originating from the neighbor cells. Here, there is no transmission at all. So in this particular case, the UEs can measure the interference or the background interference happening from the interference cell. So this will be the final figure, for example, that this particular case can now, the UE can now report accurate CQI as well through measuring the interference coming from the neighbor cells. And by the way, this is still, it can be done that the user, for example, can without the CSI-IM RS can user can detect, for example, measure first the overall signal, then try to subtract the interference coming from the neighbor cell. But this is actually, it's more complicated algorithm. That's why they introduce this CSI-IM resources just to try to simplify it as much as possible. And this is actually a new concept also adopted by the 3GPP. So moving to the next type, it's about the zero power reference signal. As I told you, zero power is like kind of a misleading name, because actually the resources of zero power still the GND can transmit information with this one to transmit some information to the UE. Okay, for example, the figure on the left here, you can see this figure on the left. It's showing, as you can see here, this is like I consider it as BDCH, and you have BDCH resources, and you have some gray information which is having no data. And you have some CSRS for IM interference management, and for some of non-zero power. The main idea here that sometimes that the transmission of the CSRS for IM and CSI-RS for non-zero power doesn't fully occupy the corresponding frequency domain resources. As you can see here, you have still a few resources. And these free resources, we would like the UE to use it like to increase or maximize the gain of the throughput and so on. So this, for example, can be used for BDCH. So here is where the zero power come into, or the zero power resource element come into the figure. What will happen? The GNB will convert these resources into like it will be using this zero power configuration to inform the users within these particular resources, as you can see here, that these resources are being free. You can be using these resources are being free. For example, no data being transmitted here, so you can start using for BDCH. So this is the main concept. It's called rate matching feature. This is the main concept. Zero power is being used to inform the UEs about the remaining frequency domain resources for mapping data to increase the maximum or to maximize the gain of the throughput and so on. So this is one of the most important or the most main function of zero power. Actually, next part, it will be about the parameters. Yeah, it's about actually first, before moving to the parameters point of view, I just need to cover the TRS tracking reference signal. This is actually a tracking reference signal, as I mentioned in the first slide. It's a subset of the CSI-RS. It's actually adapted by CSRS as a solution for the TRS. What it means by this, that it's exactly the same concept. Some of the resources are being used, transmitted here. This is CSI resources as well, but it's used for tracking the frequency and time domain in order to make like the like try to improve the UE ability to track time and frequency offset and so on. And actually, the main idea of this part that the TRS is using higher density, and this one try to improve the ability of the UEs to track the time and frequency offsets. And there is additional features called rate matching. This is actually not very part of this part, but I'll try to add it here to just to cover this part as well. This additional feature of the rate match of the TRS, it's TRS rate matching. This is actually it's the vice versa. No, opposite, for example, for the previous one, which mentioned the zero power. For example, here the used resource of BDCH will be truncated, as you can see here. It will not use for anything. no transmission here, and this is mainly used, why it's being used, just to avoid, for example, the interference caused by neighbor cells. Assuming that you have another neighbor cells using different locations of the TRS, so there will be interference between all of them, that from the TRS, for example, to BDCH. So this part is just using to avoid the interference caused by the neighbor cells. So that's why, as I mentioned here, for example, the serving don't interfere with each other, neighbor and cell, and this can eliminate the interference and help to improve the SNR. So this is one of the function as well. Actually, we still have many parts to cover. I will cover this in next session. As you can see, we have many parameters. I will go for details for each and every single of those parameters, and we'll try to visualize in next sessions. So stay tuned, and please press like and comment if you like the session. And all the materials will be shared in the video descriptions in case if you need into it. And please drop a comment if you need any more information and so on. Thank you very much.